and I'm Jian, and I'm from the Joint Center of Fujian University in Taiwan. And today I'm going to introduce a web-based platform that integrated geographic information system with a sustainable land use model. First, I will introduce why we did this and a brief introduction to system approach to land use sustainability or SALUS model. Next, I will talk about the system design. Then I will demonstrate how one can use it. Then finally, conclusion. Okay. First, according to the statistics from the United Nations, we are facing a lot of environmental problems in the 21st century, like climate change, or soil erosion, energy consumption, etc. And besides another problem we are facing now, besides environmental issues, is the population growth. Now, there are almost 7 billion people in the world, and after 20 years, may could exceed 8 billion. That is a very crazy increasing rate, and all the future population will occur in the developing country like countries in South Asia, Africa, or South America. And the increasing population means will bring an enormous stress on the environment. And most people miss more mouths to feed and higher demand on land and water. And nowadays, and the agricultural land has exceeded the area covered by forest land and woodland. And the agricultural land increased rapidly year by year. And due to the population growth leading to increasing basic protein requirement, there is a great need for an ever more productive agriculture that protects and promotes environmental integrity rather than degradation. So let's move to the SALUS model. And SALUS stands for a system approach to land use sustainability. And what can it do? Briefly, a SALUS model can simulate the variation of crop and soil conditions under the continuous weather data and different management strategies. And there are some scenarios that could help you to better understand what can it do. First, if I want to know how much the crop yield is if I use 200 kilogram and 100 kilogram fertilizer per year, and SALUS model can tell you how much the crop yield is under two different separately designed strategies. And second, regarding the global warming, the SALUS model can calculate the amount of the CO2 emission from the field in the cultivation. And third, what kind of agricultural management will make my field degradation and vice versa. And SALUS model also can tell you how to achieve a sustainable development and avoid soil degradation. This diagram shows the workflow of the SALUS model. And the input data consists of weather, soil management, and crop data. The weather data is composed of the temperature, precipitation, and the solar radiation. The soil data consists of some chemical and physical property of the soil. And the management data is the man-made activity to the farm, like planting, irrigation, fertilization, harvest, etc. And the crop data include the genetic property of the plants. And this input data will be calculated by 3 different modules in the model. And the model will produce hundreds of outputs. And we could categorize the outputs into 3 different groups: crop, soil, biomass, and soil water balance. And the outputs could consist of like yield or leaf area index, or organic matter in the soil, or soil water content. Okay. And so we know the SALUS model is a very robust environment model. And originally, SALUS model was a desktop software which chart and tables were used to present the results. So now the Salus WebGIS integrate Salus model and GIS into a web-based platform, and it can help people to better understand the spatial variability of the output from the model. And like we could create some crop yield map or soil condition map. Okay, this web application follows a three-tier application, three-tier architecture. In the database tier includes Microsoft SQL Server and GIS data, and the middle tier includes a map server and a web server. The web application is developed by the ASP.NET and Ajax, and the server could also provide a camera service that follows OGC standards, and this service could generate camera file, which is compatible with the Google Earth. Okay, regarding to the database design, the Salus WebGIS adopted G3 shapefile to be the source of spatial data, and the geometry type was limited to the polygons. And polygon features were used to display the spatial variability of the simulation, and each polygon will record a specific soil data, weather data, and the management data. And similarly, the simulation result will append it to the attribute of the polygons. And this slide shows some key features of this web platform. By using the WebGIS platform, people could visualize the simulation result into the map. And it also provides users with the ability to digitize the interest area on the Google Map by themselves. And one can use shapefile or coordinates file on their choice, and the users from the previous desktop version could use the same data in this platform, and they can upload the desktop version data to create the simulation. Okay, let's take a look at some system implementation. In this platform, if people want to know the relationship between the measurement data and the measurement strategies, they could upload the Excel file with XY and draw the area of interest for simulation. For example, if people want to know the relationship between the spatial variability of leaf area index and the management strategies, they could draw some areas with higher value and lower values respectively in this interface, and it can help users to convert XY table into point data. Okay, if user cannot provide spatial data, or some user may not be familiar with GIS, they could digitize a specific area on Google Maps in this platform. User could take the advantage of the Google Map, which has the satellite image worldwide. And through the image, user could recognize the fields that they want to simulate easily and digitize them. And this polygon digitized by user will be stored in the web platform and become the basement to visualize the simulation result. And after simulation is done, the simulation results are displayed in the time series choroplast maps. And here we have 4 different thematic maps in this platform. They are crop yield, and nitrate leaching, and CO2 emission, and soil carbon differences. And in the bottom of the map, there's a time slider that the user can use to change the map display by ear. And the time series map can be exported to camera file that is compatible with the Google Earth. Okay, in the conclusion, I would like to say that the Salus WebGIS have overcome the limits of the point-based model in visualization and display the spatial variation and temporal variation of the results. And Salus WebGIS can help decision makers understand the applicability of various management practices to relevant regions. And this new tool can help environmental managers achieve the sustainable use of the agricultural land. And thank you for your attention. If there is any questions, please feel free to ask. Thank you.
Okay, Patrick, comments?
I have a small question. The first question is, I said you said model.
Yes.
But the logical data and the function may come from different research centers. How do you integrate them together based on web service? And the second question is, logical data from different research centers. The category system may different from each other. It can be said that has some semantic difference. Semantic difference.
Mm-hmm.
How do you deal with it?
Okay. Okay. First question. This model is focused on agricultural land. So if you want to simulate the field, we have to prepare the weather data, soil data, and the crop data in advance. Without this, the input data, we cannot simulate. We cannot create a simulation. Yeah. So regarding the second question, this model is focused on the agricultural land, only for agriculture. Yeah.
Any other questions or comments?
I have a small question.
Yes.
You just mentioned the title and copy of the GIS and the,
yes.
and the use model.
Yes.
What's the limit, the title and copy?
Okay. The type copy, okay, this is according to some according to other research. The type copy means it means we cannot like sometimes in the past there are many examples that is about connect GIS with the model. So some models they are integrated in people have to extrapolate the model first, then they convert the data into GIS. But in this platform, we totally integrate with the model and the GIS. People don't have to change the interface. They can complete the simulation in one interface.
Okay. You just select the Google Earth as your web pages.
Yeah.
And is enough for your land use modeling?
Yes, because actually the Google Map is just for the digitizing. Yeah, but we have another map system, yeah, to display the simulation result. Yeah.
Any other questions? Thank you.